Alright, let's dive into something that's blowing my mind right now. Freshwater discovered beneath the Great Salt Lake. Yeah, you heard that right. The Great Salt Lake, known for its, well, saltiness, might be sitting on a massive underground reservoir of freshwater. And no, this isn't some sci-fi plot twist, it's real science, and it's fascinating. Here's the deal. Researchers from the University of Utah used this high-tech method called airborne electromagnetic (AEM) surveys to basically X-ray the ground beneath the lake. What they found is wild: freshwater saturating sediments up to 10,000 feet deep. Let me repeat that, 10,000 feet. That's nearly 2 miles down. What makes this really interesting is that it challenges everything we thought we knew about how freshwater and saltwater interact in these environments. Personally, I think this discovery could be a game changer, not just for Utah but for how we think about water resources globally. Now, let's zoom in on how they figured this out. The team, led by Michael Jdanoff, used helicopters equipped with electromagnetic gear to map the subsurface. What many people don't realize is that freshwater and saltwater have different electrical conductivity levels, so this tech can basically see where one ends and the other begins. They found that beneath the salty surface, there's this vast layer of freshwater pushing inward toward the lake's interior. Hydrologists expected the freshwater to be at the edges, not the center, because brine is denser. But here we are. This raises a deeper question. How did this freshwater get there, and what does it mean for the lake's ecosystem? One thing that immediately stands out is the potential implications for dust pollution. The Great Salt Lake has been shrinking, exposing hundreds of square miles of dry lake bed. That's not just an eyesore, it's a major source of dust storms carrying toxic metals into nearby cities. Hydrologist Bill Johnson, who's been leading this research, thinks this freshwater could be a solution. His idea? Tap into this underground reservoir to wet the dry areas and stop the dust. But here's the catch: we don't fully understand this system yet. If you take a step back and think about it, messing with groundwater without knowing the full picture could have unintended consequences. In my opinion, this is where the real challenge lies: balancing immediate needs with long-term sustainability. What this really suggests is that we've only scratched the surface of what's beneath us. This study covered just a small part of the lake, but Jdanoff believes they can map the entire 1,500 square mile area. Imagine if this freshwater isn't just under Farmington Bay but extends across the whole lake. That's a massive resource. But it also raises ethical questions. Should we even tap into it? And if we do, how do we ensure it's done responsibly? From my perspective, this discovery isn't just about water, it's about how we value and manage our natural resources. A detail I find fascinating is the technology behind this discovery. The AEM surveys combined with magnetic data inversion allowed researchers to create 3D images of the subsurface. It's like giving the Earth an MRI. This tech isn't new, but applying it to this problem is groundbreaking. It makes me wonder how many other hidden water sources are out there, waiting to be found. If this method works for the Great Salt Lake, why not other terminal lakes around the world? Closing thought: this freshwater reservoir isn't just a scientific curiosity, it's a reminder of how much we still don't know about our planet. It's also a call to action. As we face growing water scarcity, discoveries like this give us hope, but they also come with responsibility. Personally, I'm excited to see where this research goes, but I'm also cautious. What do you think? Is this a resource we should tap into, or should we leave it untouched? Let me know in the comments. I'm genuinely curious to hear your thoughts.